Hey, this is Mr. Mitchell with another video. In a little bit, we'll talk about chemical properties and physical properties. Go ahead and write down these questions first. Let's talk about the chemical properties first. Chemical properties have to do with chemical change, and the properties are like characteristics, the way a substance reacts with others to form new substances, and that's going to be the key. If it forms new substances, then you have a chemical change, and it also has to do with chemical properties. Let's take a look at this. We have a nail here. This nail did not start out with the rust on it. The rust formed after however many years of time, or maybe even less than years of time. The rust is actually a different substance than what the nail is made of. There has been a chemical change. This nail has a lot of reactivity. You know, some properties, some elements have more reactivity than others. Something like argon or helium hardly ever react with anything. Gold is another one that hardly reacts with anything. But some react with a lot of things like hydrogen and oxygen and carbon. Here we have the burning of the wood. We mentioned in previous videos that if you burn a match, then you have gases that are released into the air. Same premise here, you have a chemical change. I think we've mentioned before about antacid bubbling up, and that was a sign that there was a chemical change, that there was a new substance being formed. Now there are several signs that you have a chemical change, because you know you can't really tell all the time. Sometimes you can have a new odor if you have two properties that are mixing and you create another one. Here we have a temperature change is another way that you might know that there's been a chemical reaction. Another one is a color change. Wow, look at this. We have the blue going into yellow. I don't know if that's a Photoshop type thing, but still that kind of signifies color change. Sometimes you have a chemical change when bubbles form and it has like a gas which is escaping. There's a term called a precipitate. Sometimes when you mix things together, you have like a solid that is formed. When you mix liquids together in a solid forms, that's called a precipitate. And that usually indicates that you have a chemical reaction as well. But let's get to the physical reactions, because there's something that goes with that. Physical reactions are changes that do not involve a change of substance. Now, physical and chemical changes lead to discussion about physical and chemical properties lead to discussion about physical and chemical changes. We mentioned in another video about the physical change of the wool, like a lamb here. The wool goes through lots of changes. It can be put dyes in it. It ends up being a sweater, but it's still wool. That would be an example of a physical change. Whenever you have something like a change of color, change of shape, melting point, boiling point, that does not affect what the substance is. The substance still stays the substance. I think we use the example of water. Whether it's ice, whether it's water vapor, whether it's water, it's still water. You did not have a chemical change there. But kind of the point I'm getting to is a kind of physical change. One kind of physical change we're going to talk more in depth in is density. Now, density, like other physical changes, are constant. For example, the melting point of ice is going to be about 32 degrees. That is constant. And that's one of the things you often find with a physical change, that you have constants that go with that change. Now, density, if you have like a bowling ball in one hand and a basketball in the other, they weigh differently. And when you're measuring density, that's a little bit about what you're looking at. You have this bowling ball that is real dense. It's full of stuff. But you have this basketball which is full of air. Think about cheesecake. Cheesecake is a lot more dense than, say, angel food cake. Cheesecake just has a lot of stuff, a lot of heaviness in it. When you have a lot of stuff and heaviness in it, then you have a lot of density. Another example is like a loaf of bread and a brick. A brick may even be smaller than a loaf of bread, but it has more stuff in it. It's just more dense, and you know it by how heavy something is. Now, what tends to happen with density, and you can see there's a formula we'll actually get to doing some calculations about the mass divided by the volume. But one characteristic of density is something called buoyancy. And I did not write that on here. I probably should try to spell that out. Kind of a funny spelling word. But buoyancy has to do with things floating. And that's exactly what you can see down here. B-U-O-Y. Buoyancy, or how buoyant something is. Something that is more buoyant would float, and something that is less buoyant. So here, a less dense substance like a ping pong ball. A ping pong ball is less dense than lamp oil, which is less dense than rubbing alcohol. I'm sure they put dye in these types of things so that it'd be easier to tell. Which is less dense than vegetable oil, which is less dense than water, which is less dense than dish soap. And you can see there's this cherry tomato in here, which is probably more dense than water, but less dense than milk. Kind of odd right there that somebody's done an experiment here, which has all the less dense stuff on top and all the more dense stuff on bottom. You can see this bolt, of course, would be heavier, more dense than all of that stuff. But density is something that is a physical change and is constant. Water, for example, will have a density of 1.0, whereas a brick will have a density of 1.9, and it's going to stay the same. You keep calculating density of water, it's going to keep coming up with 1.0. It doesn't just go changing just because of different bricks. So why don't we go ahead and calculate some stuff. And we're going to do some more stuff like this in class. So let's learn how to do it now. We mentioned before, or at least it was on this slide, that density equals mass over volume. So here it says a block of aluminum occupies a volume of 15 milliliters, 0.0 milliliters, and weighs 40.5 grams. What is the density? Now, before we get to the calculations here, milliliters is pretty much equals to centimeters cubed. So whenever you see in your book centimeters cubed, then that's going to be equal to milliliters. But anyway, we have density equals mass over volume. We're substituting in the mass, 40.5 for mass, and we're substituting in 15.0 for the volume, and we're going to find the density. So take our handy dandy calculator out, and we have 40.5 divided by 15.0 equals, yes, so 2.7. Density is 2.7, and that is going to be in grams over milliliters. Like I said, this milliliters is sometimes substituted in for cubic centimeters, and that's something that you'll inevitably see in your book. Take a look at this next one. Mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. So we know what's going to go on the bottom. The mercury is used to fill a cylinder weighs 306 grams. From this information, calculate the density of mercury. I wonder if mercury will be heavier than this 2.7 grams per milliliter of aluminum. You know, remember, water was 1.0, so we're finding things which are inevitably heavier than water. I just bet mercury will be heavier than water too. So what do we have? 306 grams is the mass. So it weighs, that's the mass, 306 grams, so that goes right there. And the 22 milliliters is going to be the volume. So kind of a simple calculation here, 306 divided by 22.5, see what I can remember. 306 divided by 22.5 equals, wow, that is a heavy substance. Mercury is heavier than aluminum, more dense than aluminum, 13.6. So the density is 13.6 grams per milliliter. And these should be constants as long as these totals I have here are accurate. These should be constants. Here's something a little bit different. Find the mass of a 250 milliliters of benzene. The density is something we already know. The density of benzene is this. And you know, you could find copies of, it's easy Google search of finding what typical densities are. And this is a problem you might find with something like that, is finding the mass or finding the volume. Now we had an earlier video where you learned that you would, D equals mV would be equal to M equals dV. And what we did, we just solved for M on one side. I hope you remember how to do that. But what it turns out to be is now we have M mass equals dV. Now, wait a minute. We are finding the mass. Oh, that's right, we are finding the mass because milliliters here is going to be the volume. Okay, so we're finding the mass. Mass equals D. So density is going to be 0.8726. And then the volume is going to be this 250. So that looks like a pretty simple one. We just multiply 0.8765 times 250. Okay, 0.8765 times 250 equals 219.125. 219.125. Okay, and mass is calculated in grams. So we were able to calculate that. Benzene is 0.8765 dense, so that would be less dense than water, which would be less dense than this block of aluminum, which all would be way less dense than this mercury. Hope you've learned a little bit about how to do this, and we'll calculate some more in class.